Hello students, in this particular video we are going to learn about Ampere circuital law and their proof. Okay, so let's write Ampere's circuital law. So this law basically states that the line integral of the magnetic field around a closed loop or path is equal to mu naught times the current which is passing through that particular closed loop. Okay, so let's write Ampere's circuital law states that circuital law states that the line integral of magnetic field around a closed loop or path is equal to mu naught times mu naught is permeability is equal to mu naught times the current passing through that closed path. Mathematically we can write integration of closed line integration b dot dl is equal to mu naught into I, where current I stands for the current which is passing through that particular closed loop. So now we are going to prove it. So proof of this is, you see, if you take a circular current loop, before we take a circular current loop, let's take one straight wire. Okay, so it is a straight wire, and let us assume the current is flowing in this wire in the upward direction. Then the magnetic field, direction of magnetic field will be circular loop surrounding this wire and onto this loop. This is basically representing the magnetic field only. This is representing magnetic field. So at this point, or magnetic field loop, okay, so at this loop, along this particular loop, at each and every point the magnitude of magnetic field will be same and it will be in the tangential direction. At this point along this, so at this point along this, so this is how the magnetic field is directed at different points, but the magnitude of magnetic field at each and every point will remain the same, and the center of this magnetic loop will be falling on this wire or conductor. So this particular loop we name it as Amperian loop. Amperian loop. So whenever we apply the line integral, we apply line integral on this particular loop only. So we have considered one infinite length wire, if we say, then magnetic field at some radial distance. Due to infinite length wire, we know magnitude of magnetic field will be mu naught I by 2 pi into A. So magnitude wise it will be constant, but direction tangential, so at every point direction will be different. So now to prove this, what we need to do, we need to just consider one DL element of this loop. Let us take DL element. So this DL vector is pointing in this direction. If we take any small DL element of this particular loop, I am redrawing it. So small DL element of this loop will be pointing in this direction, and at this point B vector is also pointing in the same direction. So theta between them will be equal to 0 degree. So we need to do B dot DL. So B into DL into cos of theta, and we know cos theta is equal to cos 0. So B into DL into cos 0 degree, which is 1. So B DL, this is the magnetic field into DL element B DL. So we have to do the line integral over the entire closed path. So we are going to apply the Ampere circuital law. Line integral of the magnetic field, line integral of magnetic field, line integral of magnetic field around the circular path or it is better along the circular path. We have to write along the circular path, and that is closed line integral B dot dl, and that we have already done, B into dl. So B is constant, it will come out integration of dl. If you are going to add all the different dl parts of this loop whose radius is r, then of course this L will be equal to 2 pi into radius, that is equal to r, 2 pi into r. So here we can directly say B into L, and L is equal to 2 pi r. So B into 2 pi r. Now next to this is, according to Ampere's circuital law, we already know that B value mu naught by, what is that, mu naught I by 2 pi r only, na, mu naught I by 2 pi r only, it is infinite length. So if we have taken radius as, or distance from here as r, so we have to write 2 pi r. So 2 pi r, magnetic field due to this infinitely long wire at some radial distance r. So mu naught I by 2 pi r, and this is 2 pi r multiplied. So this two term will cancel out. So finally we got B dot dl is equal to mu naught into I. So this is the Ampere's circuital law proof. So this result is very important. Now we'll learn application of Ampere's circuital law in the next video. Thank you.